Hello friends, this video Limits and Derivatives Part 15 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched Part 1 to Part 14. Let's take one example. Here we have to find the derivative of fx where fx is equal to 3x, x is equal to 2. So when we say f dash of 2, we can use the formula. This is nothing but f of 2 plus h minus f of 2 by h limit h tends to 0. This is f dash of 2. F dash of 2 is nothing but derivative of fx at x equal to 2, and that value is f of 2 plus h minus f of 2 by h. Now we'll put the value, we'll put h is equal to 0. So this becomes f of 2 plus h is nothing but 3 into 2 plus h, because f of x equal to 3x, x equal to 2 plus h will put, this becomes 3 into 2 plus h minus f of 2 is 3 into 2, because x is equal to 2, it becomes 3 into by h tends to 0. Yeah, this is nothing but 6 plus 3h minus 6 by h, and here also limit h tends to 0. 6 cancel, and this becomes nothing but 3h by h, limit h tends to 0. H is also cancelled, so this becomes limit of h tends to 0 of 3, and that is nothing but 3. 3 is the answer. Very simple. What we have done, we are supposed to find derivative of this function fx at x equal to 2. That is, we were supposed to find f dash of 2. F dash of 2 is nothing but limit of f of 2 plus h minus f of 2 by h. This formula we had, and we have just solved this to get this value is 3. We'll take one more example. We have to find the derivative of this function 2x square plus 3x minus 5 at x equal to minus 1. That is, we have to find f dash of minus 1. F dash of minus 1 is nothing but f of minus 1 plus h minus f of minus 1 by, let's say, by h, limit h tends to 0. Correct? Now let me put the values. F of minus 1 plus h is equal to nothing but, we'll replace x by minus 1 plus h. So this will become 2x square, that is 2 into minus 1 plus h square plus 3 into minus 1 plus h minus 5. This is f of minus 1 plus h minus f of minus 1, that is 2 into minus 1 square plus 3 into minus 1 minus 5, correct, by h, the whole thing by h. Here also we'll say limit h tends to 0. This is the value, correct. Here if you see 5 and 5 will get cancelled, minus 5 minus 5. We'll solve this, what we'll get here. So this becomes 2 into 1 plus h square minus 2h, correct, and this becomes, I'll take 2 common here, minus 1 plus 3 into minus 1 plus h minus 1, minus and minus is plus 1 here, this cancel. So minus 1 plus 1 cancel, and minus 1 plus 1 cancel. So what we get here is, here this also is limit h tends to 0, the whole thing divided by h. So what we get here is 2h square minus 4h, right, by or plus 3h by h, limit h tends to 0, correct. Or the same thing we can write is limit h tends to 0, 2h square by h is nothing but 2h, and minus 4h plus 3h because minus h, and minus h by h is 1, correct, because I write the same thing here, is nothing but 2h square by h minus h by h. This comes out to be limit of 2h minus 1, where h tends to 0. And if you put the value of h equal to 0, this becomes 2 into 0 minus 1. So that becomes minus 1. So this is the value of this function at x is equal to minus 1. So f dash of minus 1 is equal to minus 1. That is the answer. So what we have done here, we have found the value of f dash minus 1, that is limit of f of minus 1 plus h minus f of 1 by h. We solve this to get the value to be minus 1. Here we have to find derivative of sin x at x equal to 0. So here also we will write f dash 0 because x equal to 0 we will find. This is nothing but f of 0 plus h minus f of 0. The whole thing divided by h, and we say h tends to 0. Correct? So this comes out to be sine of 0 plus h minus sine 0 by h, where h tends to 0. This is the value. Now sine of 0 plus h is equal to sine of h. So I'll write this as sine of h by h minus sine 0 is 0 minus 0 by h. Limit h equals to 0. So limit of sine of h by h where h tends to 0, we have this formula. Sine x by x where x tends to 0 is nothing but 1. Correct? So here x is nothing but h. So this value will be 1. So this becomes 1 minus 0. And that is equal to 1. So derivative of sine x at x equal to 0 is nothing but 1. What we have done here? Same thing, we have used the same formula. F dash of 0 is nothing but f of 0 plus h minus f of 0 by h, where h tends to 0. We have solved this and we have got the. Here we have to find the derivative of this function fx is equal to 3 at x is equal to 0 and x is equal to 3. That means we have to find f dash 0 and f dash 3. Correct? So let's find f dash 0 first. F dash 0. F dash 0 is nothing but f of 0 plus h minus f of 0 by h. Limit h tends to 0, always. So this becomes f of 0 plus h is nothing but 3, because value of any function is 3 and f of 0 is also 3 by h, where limit h tends to 0. So this becomes nothing but 0 by h. Correct? This is 0. Similarly, f dash of 3 is nothing but limit of h tends to 0, f of 3 plus h minus f of 3 by h. Correct? So this becomes limit of h by 3. F of 3 plus h is 3 and f of 3 is also 3. F of any number is 3 actually. What is h? This is nothing but limit of h tends to 0 of 0, and that value is nothing but 0. So we have got the answer. F dash of 3 and f dash of 0. Both are 0 in this case. Very simple. What we have done, we have just applied the formula. F dash of 0 is nothing but f of h minus f of 0 by. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.